Today, we will continue our topic devoted to intermolecular forces. If you watched my previous video, there we were talking about London dispersion forces. And today we will talk about another type of intermolecular forces, that is dipole-dipole interaction. So first let's have a brief overview of intermolecular forces. Here you can see again that book which I used for preparing these materials. And let's see, so if you remember, we have two types of intermolecular forces, which can be between electrically neutral molecules and between electrically charged molecules. So the first type, which occurs between electrically neutral molecules, can be van der Waals forces and hydrogen bond. Well, van der Waals forces can be divided into London dispersion forces and dipole-dipole interaction. So last time we discussed London dispersion forces, and today we will discuss dipole-dipole interaction, and we can see that dipole-dipole interaction itself can divide into two types, Keystone force and the BF force. So first of all, let's figure out what kind of interaction it is. From the name it can be clear that it occurs between dipoles. What is dipole? Well, dipole is such a molecule which is polar. How it happens? Like we know that molecules, these polar molecules, have a partially positively charged part, like charged atom, and partially negatively charged atom. So this molecule, it becomes like a bit long, as you can see schematically in the picture. Like one part is partially positively charged, the other part is negatively charged, but overall the molecule is neutral. So when two dipoles come into interaction, like you will see the positive side of one dipole and the negative side of another dipole can attract to each other. We know plus and minus, they are attracted. So imagine two dipoles are coming together, and what happens? Plus and minus of two different dipoles are attracted. Like the negative charge of one dipole turns to the positively charged side of another dipole, and they start attracting each other. But there can be also repulsion forces. If, of course, if two positively charged or if two negatively charged sides of dipoles turn to each other, there will be repulsion forces between them, as you can see in this picture. From the same book, I take this picture that you can see on your screen now. This screen shows attractive forces and repulsive forces of a solid CH3CN molecule. It's another example. Now, to understand this kind of interaction better, let's take two examples, acetonitrile and propane. Let's take two molecules. We see that the molar mass of acetonitrile is 41 and boiling point at 355 kelvins. While about propane, its molar mass is 44 gram per mole and boiling point is 231 Kelvin. Let's now discuss these two molecules. Let's pay attention at their boiling points. So let's go more detailed now and understand this phenomenon. Acetonitrile. It is a polar molecule and it even has a dipole moment. If it has a dipole moment, it is polar. It means it creates a dipole, this molecule. It has a positively and negatively charged sides. That means that between these molecules, in the case of acetonitrile, there are dipole-dipole forces they present. If we consider propane, propane is a non-polar molecule. it has no dipole moment, or even if it has a dipole moment, it's very low, it's close to zero. So propane is nonpolar, has no dipole moment. Of course, if it's nonpolar, or we can say apolar, it does not create dipole. And for sure, dipole forces are absent in this case. Now let's have a look at the molecular masses or molecular weights. They are approximately the same. 41 and 44, they have similar molecular weights. Then why? Why is there such a big difference in boiling points? It is because dipole-dipole forces. When there are dipole-dipole forces in a molecule, boiling point increases. Why? Because there is interaction. Two dipoles, like positive part of one dipole and a negative part of another dipole, they attract each other. There is some attraction. It means boiling point will be higher because we need more energy to break this interaction and make these molecules fall apart. While if there are no dipole-dipole forces, of course, it will be easier to separate these two molecules, so the boiling point will decrease. Let's see at this picture, which is taken from the same book. Here we can see four molecules: propane, dimethyl ether, acetaldehyde, and acetonitrile. And if we pay attention on their boiling points, we can see that when dipole-dipole interaction strength increases, boiling point also increases. Dipole-dipole interaction can be divided into two types: Keystone force and Debye force. If we are talking about Keystone forces, these forces occur between permanent dipoles. Like if we have two polar molecules, between them there will be Keystone forces. These forces originate from the attraction between permanent dipoles, so dipolar molecules, and they depend on temperature. So Keystone forces are temperature dependent. What about the Debye force? They occur between a permanent dipole and induced dipole. But how do these induced dipoles occur? Let's think. What is induced dipole? A molecule with permanent dipole can induce a dipole in a similar neighboring molecule and cause mutual attraction. Have a look. We have an atom A and atom B. We know that electrons are constantly moving inside the atom. They are not on the same place, but it can happen if we just frozen an atom, theoretically, stop an atom for a moment. At one moment, the electrons will be on some place. And it can happen that in some moment, in some certain moment, both of the electrons are, let's say, on the left side of the nucleus. It means that this atom will have the left side, which is negatively charged, and right side, which is positively charged. What it means? It means that for that moment, for that instant, our atom will be a dipole. This is called induced dipole. Well, let's now continue. Debye forces cannot occur between atoms. I mean, between electrical and neutral atoms. Atoms are neutral. They occur between permanent dipole and an induced dipole. Keystone interactions depend on temperature, while Debye forces, Debye interactions, do not depend on temperature. Let's have a look at this table. In the previous video, I was talking about the same table. Just this is the table which shows how to determine which which intermolecular forces present in our molecule, like between our molecules. More detailed explanation is given in the previous video. Well, that's all for today, and our next video will be devoted to hydrogen bonding. See you in our next video. Bye.